Good day and welcome to my presentation. My name is Alvaro Lau and I want to introduce you to our work published this year regarding tropical tree biomass equation from terrestrial LiDAR. The purpose of our work. We know that allometric models work pretty well estimating AGV biomass, especially for small trees. But what about the large trees, DBH more than 70 centimeters? Does this perform pretty well? Already, Kim Calders in 2015 showed that large trees are not over-harvested and measured for the calibration of allometrics. This results in large absolute error with increasing DBH. As we can see here, the larger the tree with the DBH, the larger the error. While on terrestrial LiDAR, the error does not vary despite the increasing DBH. Raises question regarding the national greenhouses. Am I choosing the most adequate pantropical equation for my MRV reporting? How we did it? We have three components. The first component is TLS-derived measurements. We use the BZ400 Regal TLS to estimate diameter break height of the tree, and crown diameter. We record the species and the wood density from the global wood density database. We have a total of 72 trees with a range from 11 centimeter DBH to 150 centimeter DBH. We elaborate 5 models using strictly DBH data and different combination of these parameters, as you can see. We have the TLS 3-point cloud, and then we downsample using 3sec from Andrew Bird. Then we separate the softwood from the hardwood using Matteo Vicari's TLS separation. And finally, we estimate the volume of the tree using Pasi Ramonen's 3QSM. The component involve the traditional measurements, estimating height, diameter, and breadth height. And we use 5 common pantropical models used. 4 from Chave, 2 from 2005, 2 from 2014, and 1 from Maxime Rijomichain. The validation dataset involves the harvesting of trees using destructive harvesting and the fresh mass sampling. This becomes our reference dataset. Finally, we compare the first component, the TLS-derived allometric models, the pantropical allometric models, and the compared against the validation dataset, which is the harvested trees. What we found? Our results show that our best pantropical models include crown diameter as model 4 and model 5. We also found that pantropical models perform good. Locally developed allometric models are not always better. As you can see here, Chave 2005 equation 2-3 performs quite well. Our results also show that pantropical models tend to underestimate the AGV of large trees, as you can see on the top right of your screen. The big picture. Our approach can be used to test and choose existing allometric models for remote sensing missions. We need to validate this technology or methodology in more countries involved in monitoring, reporting, and verification systems. It helps us to demonstrate the use of the new IPCC guideline using new technologies such as TLS to derive allometric models. And a task to do is to assess the impact of using these models in national greenhouse inventories. Thank you very much. As a take-home message, we're able to develop, test, and choose allometric models derived from TLS parameters. My name is Alvaro Lau, and I'll be around during this conference, so you are always welcome to reach me. Thank you very much.